Hello and welcome to Chapter 3. In this chapter, we're going to learn more about the principles of the MapReduce programming model. We'll be getting a better understanding of the purpose of both the map process and the reduce process. We'll see how these enable a processing task to be split over multiple computers, and we'll write some sample Java code using these concepts. Let's start by having a look at the principles of MapReduce in more detail. Before we start using Hadoop, I think that being able to think in a MapReduce way is so important that it's worth writing some standard Java code together first using the principles of MapReduce to undertake a processing task. This will help us see exactly what a map task needs to do and what a reduce task needs to do. Now, this is not going to be Hadoop code. In fact, it isn't really even the Hadoop way of doing it, but this is an exercise to help us understand the concept of map and reduce a little better. We'll then be able to apply these concepts to the Hadoop MapReduce programming model. So our starting point for the exercise is we need some kind of processing task. I've got here the opening speech from the play As You Like It by William Shakespeare. Now, this could be any text at all. I've chosen it because this piece of text is freely available and it's no longer in copyright. There's no other reason. Let's find out what are all the words within this text with 7 or more letters in them. So I can see, for example, there's the word remember, that's got 7 or more letters. We've got fashion, we've got bequeathed. It looks like there's going to be quite a few of them. Well, I've written some standard Java code to do that. It's not MapReduce code, just some standard Java. There's a copy of this project in the starting workspace folder for this chapter. You'll find that in the practicals and code folder. And what I'd like you to do is open up this project in Eclipse. So to do that, copy the whole folder and place it somewhere on your hard drive. I've placed mine here just in a folder called Hadoop Code, and that's going to be my workspace when I open Eclipse. So let's start Eclipse up now. And I've set my workspace to be this folder called Hadoop Code. I've placed my Java long words analysis folder within Hadoop Code. And we'll close the Eclipse welcoming screen. And then to load up the project, I'm going to do a new Java project. Now the project name needs to exactly match that folder name that we copied in. It's case sensitive and it was Java with a capital J, long word analysis. If you've typed that in correctly, you should have this message here at the bottom of the new project screen. The wizard will automatically configure the JRE and the project layout based on the existing source. If you don't see this message, it means you've either mistyped the project name or you've not copied the folder into the correct location. As long as you've got those right and you've got this message, just click on Finish. Let me just tidy up my workspace a little bit. I'll just close these windows that I don't want to see, and we'll expand our project. And we'll see we've got here a number of classes. So let's have a look at the code in this project. Well, to start off, there is a class here called As You Like It. This is just a class that contains the text of the first speech in As You Like It, and we've defined that text as an array of strings. I've declared this as public and static just because it means I can use it elsewhere very easily in my code. So let's now have a look at the first class I've written called Standard Analysis. This does my processing task using standard Java code. We're not using the MapReduce principles yet. As you can see, we create a new array list of strings to store the output, and I'm calling that array list output, and then we loop through each of the items in the asyouLikeIt.text array. That was that public static variable containing the text of the speech. And as we loop through each string, we do a little bit of manipulation. We remove any characters that aren't either letters or spaces. This is just using a regex expression. Don't worry too much if you're not too familiar with regex. Just appreciate that this particular piece of code here will remove any punctuation marks or any other characters such as numbers. And we convert it into lowercase. So we do a little bit of manipulation of the underlying text. I'm then splitting each line into a list of separate words. I'm using the split function passing in a space, so I now should have an array of individual words, and I can loop through each of those words, check to see if the length is greater than 7, and if it is, add it to my output. So let's run this standard analysis code to see that that works. I've got a main class here, and all that does is instantiate standard analysis, call the analyze method, and then print out to the console each of the words that were produced from my standard analysis method. So let's run this now. And here's my console window, and we can see there's our first 3, remember, fashion, bequeathed, but actually there's quite a lot of them. In fact, I printed out the total here, there were 28. So that's the standard Java way of doing this kind of analysis. Now let's have a look at the MapReduce way of doing it. I want to pretend that I have a number of computers that are going to do this job, and so each computer will have one line of my as you like it text to work with. So the first computer will look at the first line only and say, are there any words here which are 7 or more characters? Well, yes there are. It should identify there's words like remember, fashion and bequeathed. We'll output a list of those words. The next computer will look at the second line and find words such as begins, sadness and brother, and the third computer will look at the third line, and so on. When the map process has finished, each of the computers will have analysed the text that it has and produced a list of all the words where there are 7 or more letters. For now, each map task will output an array list of strings. Next, we'll want to combine these lists together, so we'll run a method called reduce on each of those output array lists to produce another list which will be a single list of words. As part of this process, we'll remove any duplicates. So I've written some code that does that. Let's have a look at that now. So this time we want to go to the class called MapReduce Analysis. I'm going to start at the bottom of this class, and we can see that in my analyze method, what I'm now doing is calling a function called map on each of the lines from my as you like it text, and I'm storing the results of that map method in a separate array list for each call. That's meant to simulate this working on 8 different computers. I know that if you were writing this to run on a single computer, you'd write code using a loop that would look much more efficient, but to show this is 8 separate computers, I've written it out as 8 separate calls to the map method. I'm then calling the reduce method on each of those separate outputs and passing back the output. So let's have a look at the map and reduce methods. Well, the map method is very similar to what we've already seen when we did it in standard Java, and that's what we'd expect to see. So I'm creating an array list of strings, which I call result. I do that same code to remove any spurious characters and convert my text into lowercase. I'm then splitting the text into single words, checking if the word length is greater than or equal to 7, we then add it. The only difference between this code and the code that we saw in our standard Java analysis is that we're working here with a single line rather than an array of lines. Now for the reduce method, I've created up here a variable called output, which is going to store the result of all of my reduces. So as each reduce method runs, it takes in an array list of words, it loops through those words, checks we haven't already got the output in our list, and if we haven't, it adds it. Now this isn't quite the way Hadoop works, but I think it's useful to see that we've created a map and reduce version of our standard analysis. Let's run this and see what the results look like. So I'm going to go back to my main method, and now instead of calling standard analysis, I want to create an instance of my MapReduce analysis class, which we'll call MapReduce analysis. And I want to retrieve a list of words called long words and set that equal to the result of the analyze method of my MapReduce analysis class. So I'll save and run that now. And once again, we've got 28 output we start off with those remember, fashion and bequeathed. So our MapReduce code has produced the same results as our standard analysis, but by writing our code in this way, we could, in theory at least, have had each line being processed by a separate computer. It doesn't matter what order these lines run in. I could change the orders round. I could have 0, 1, 6, 3, 5, 4 and 2. And I'll get the same results. I'll just save it and run it to prove that's the case. Okay, well, we'd need to sort them to get the same results, but I've still got 28 here. So the order isn't important. And we can see that it's the reduce function that does the hard work of bringing back the results. And in our instance, all it has to do is check that we haven't already got the word we're looking for in our master list. So far, we have been dealing with array lists. There aren't any maps in my code here, and you might remember that I said that Hadoop requires the output of our code to be in the format of a map. So let's have another example that takes us a step closer to the Hadoop way of writing MapReduce code. I'd like you to have a go at this task this time. I'd like you to create a piece of code which calculates how many times each of the letters A, E, I, O and U appear in the text from As You Like It. You'll need to create the code using a MapReduce structure, and I've created the outline for you, which I'll show you in just a moment. So the task now is to write a function called map, which will do the calculation on a single line of text and return the results. This time the result should be a map. I suggest you use a simple Java hash map for this. The results will be made up of the letter, which will be the key, and the number of times it appears in that line, that will be the value. Then we'll create a second function called reduce, which will aggregate the results of the map functions into a new map. So I've created a structure for you to use in this task. If we go to our class called MapReduce val count, I'll just make this window a bit bigger. At the bottom here, I've got an analyze method which calls our map function, which you're going to write, and stores the result as a hash map of strings with the key, integers with the value. And then we're going to call our reduce method and put into our reduce method each of those different outputs. Once again, this code could of course be written much more efficiently using a loop, but I've put this in full to make the point that we are simulating each call to the map method taking place on a different computer. It's just to make it really clear while we're learning about MapReduce, this isn't intended to be an example of production quality code. Let's have a look now at the reduce method. Here I've created a variable called output, which is an empty hash map, and I'm creating some initial values in our output of 0 for each of the vals before our reduce methods run. So your job is to write code in the map method and the reduce method. I've got on screen here what the final result should look like. So if you write this code and get the same results as you can see on screen here, then well done. If you get stuck, don't worry, there's going to be a full run through on this video in just a moment, and there is some sample code in the practicals and code folder for this chapter, so you can compare your code to mine to see where you've gone wrong. You can pause the video now and give this a go. If you get it working, you don't need to watch the rest of this video. All that's going to be on here is the walkthrough of this exercise, and I'll see you in the next chapter. Okay, so we'll have a go now at writing the code that does this piece of work. So I'm in my MapReduce val count class. I'm going to my map method. And the first thing I want to do is to set some initial values in my result hash map of 0 for each of the 5 variables we're trying to find. So let's just do that. So that's A. We'll just copy this in 5 times and change the letters. E, I, O, and U. Okay, so we've now got our results hash map prepared. Now we want to loop through each of the characters in our line string and see if they are A, E, I, O, or U. I think we'll do this by creating an array of characters from the string. So let's do that here. We'll do char with square brackets for the array. Let's call it chars. and we'll set that equal to our existing line. That's what was passed into this method. We'll call the dot to lowercase on it because we'll want all the characters in lowercase, and then we'll convert that to a char array. Note that this time it doesn't matter if we've got characters in this string like punctuation marks, because what we're going to do is say, is this particular character one of the A, E, I, O or U, and only do something if it is. So I don't need to strip out any full stops, for example, or question marks, because they'll just get ignored anyway. So we've got an array of characters. Let's loop through that array. So we'll do for each character, let's call it letter this time, and that's in our array called chars. We're going to look at our result hash map and say, does the letter appear as one of these keys? Is it one of these A, E, I, O's or U's? Now we're going to have an issue that our letter is of type char and our keys are of type string. So I think it'll make life slightly easier if we create a string version of our current letter. Let's call that S letter. And I'll set that equal to string.value of our existing letter. Does our result hash map already contain a key that matches that letter? So I think we've got a contains key. Yes, we have. So I think we can do if that evaluates to true. If our result hash map does contain a key that matches that letter, then the letter is one of A, E, I, O or U. So what we'll want to do is say, take the result hash map and put a value for that letter, which is S letter, and the value is the existing value from the result hash map plus 1. So there's not too much code there, but let's just talk it through again. We get passed a string into this particular method called line, and then what we are doing is converting it to an array of characters, looping through that array, and saying, for each letter, does our hash map called result already contain a key that matches that letter? If it does, then the letter is one of A, E, I, O or U. So what do we want to do? We simply want to add 1 to the existing value for that particular key. Now let's have a look at the reduce method. We've got our master hash map up here called output, and in the main method we set initial values to A, E, I, O or U. So again, I should be able to loop through the hash map that's passed into this method called letters and take each key and add its value to our master output hash map. So let's write the code to do that. We're simply going to have a for loop. We're looping through the keys, which are strings, and let's call it key this time. And it's from the keys within the letters hash map. So we can get that from letters.keyset. So that's saying for each key within the hash map that's passed into this method, what do we want to do? We want to take our master output hash map and set its value for that particular key to be the existing value for that key from the master output hash map plus the value for that key from the hash map that's passed into this method, which is called letters. So I think that should take care of both our map and our reduce methods. Let's go to our main class and we'll write some code to run this new val count class and produce out the results. So let's remove all this code here. And what we need this time is a new instance of our MapReduce val count class. I'll just call this one MRVC. I want to call the analyze method of my MapReduce val count, and that's going to return an object of type hashmap with strings and integers. Let's call that results. And so we're setting that equal to mrvc.analyze. And now what we can do is just print out each of the letters and the results of that letter. So we'll do system.out.println, and we're printing out the letter A, a space, a colon, a space, and then I want to add on results.get A. Okay, let's repeat that for the other letters. And if I save and run this code, and there's our results. I hope you followed along, I hope you got that working. If you did, well done.